now let's create my xclock as a highly available application. This is just a little cluster of two nodes, Berlin 1 and Berlin 2. I've already written a simple shell script to use as the action script for my clock resource. Here it is. Script is clockaction.sh. Begin by launching a Bourne shell. Set my display variable to my X server, which is here. And then set the variable xpid to the process ID of the clock if it's actually running. I'm just using ps to extract the PID and save it into xpid. Now, a resource action script must take one argument, $1, and that argument can have one of three values. If I run the script with the argument set to start, I'll launch a digital xclock. If I run the script with the argument set to stop, I'll kill the process of the clock, which was calculated there. If I run the script with the argument check, we'll see if the process ID actually exists. And if it does not equal an empty string, we'll return 0. And if it does equal return an empty string, then we'll assume that the clock is not running and return 1. So that's my action script. Then I have to deploy the script to the grid infrastructure home on each node. And there's a particular directory where the script should go. So cp clockaction.sh to that directory on this node. And I need to deploy it to the other node as well. So I'll scp it across the network to the other node in the cluster. Does the script actually work? Well, I'll run it with the start argument. There it is. Try it with the stop argument, and it stops. So the script looks good. But that was running the script from a Unix prompt. I need to register this as a grid infrastructure managed resource. Well, this is the command I showed you on the previous slide. crsctl add resource myclock as a cluster resource, the attributes being the action script, then the nodes on which we are allowed to start it, and what to do in the event of failure. That's got it registered, and if we take a look at the registration in the Oracle Cluster Registry, there it is. Name of the resource is myclock as cluster resource. It's currently offline because we want it to be offline. So, let's start it up. Just using the normal crsctl utility, crsctl start resource myclock. And it's started. There it is. Notice running on Berlin 1. I didn't actually know on which node it would start, and of course my users don't care, because in a more sophisticated example, the virtual IP address would have also been started on that same node. Now, let's demonstrate the fault tolerance by killing the process a few times. So detect its PID, ps-ef grep xclock, and kill -9. There it is, 8843. And after I kill it, within 3 seconds, because of the way it was registered with a check interval of 3, within 3 seconds it should start up again. 1, 2, there it is, restarted. And it will now be on a different PID. So, let's kill it again. Restarts virtually instantaneously. Kill it a third time. And look at that. It's restarted, but it's bounced over to the other node. And the proof of that is it running on this node Berlin 1? No, it isn't. But if I go to my node Berlin 2, there it is. So, that's pretty cool. Every time it dies, it gets restarted, and after a certain number of failures or attempted restarts, it moves to a different machine. And I could repeat the exercise of killing it a couple of times on the machine where it is now, and we'd see it bounce back to the other node. But now I'll just stop it in orderly fashion using crsctl stop resource myclock.